we're going to define a few things. From here on out, if I say factor completely, it's basically factor till you can't factor no more. All right? Go as far as you can. Basically, it's factored till you can't no more. All right? That's what I mean by that. No, that's not a technical definition, but that's what I mean, okay? So far we've been factoring in the sense of, hey, we're factoring this, we'll do it once. Yes, that's true. But sometimes you can go further again and again. So for like example, if I had, which one is it? Nope, not that one. This one? Yes. So for example, if we did this, 3x squared, 3x cubed minus 18x squared plus 24x. All right. Well, I can factor all of those. I can factor out a 3x out of all three of those. All right. So I can divide all three of these by 3. I can also factor out an x out of all three of those. Okay. So the first one divided by 3x is just an x squared. The second one divided by a 3x would be a negative 6x, and the last one would be a positive 8. All right? Don't worry about following how at the moment, just kind of get it down and go from there. Now, that's one type of factoring, dividing things out. The other type would be what you're probably used to thinking of as factoring. That part where we pull out our parentheses, and we do the left side multiplies up to the left, and the right side multiplies up to the right. So, two things that multiply to x are x times x. And the two things that multiply to 8, but will get us back to that negative 6, would be negative 4 and negative 2. All right, that is factored to completely, because there's no more x squared to divvy out. There's nothing else I can divide out. Okay? That is factored till you can't factor no more. No more. All right? And this is Texas. We can say that if we want to. All right? My worst fear is us moving to Pennsylvania or something silly like that, and I start using all these colloquialisms. They look at me like, you must be the most backward in-bed redneck I've ever seen in my life. I'm like, you need to come to Dallas and meet a redneck. But that's okay. All right. Ricky, pleasure to see you again. I know. I've already counted you absent. We'll fix it later. Factor by grouping. Factor by grouping is basically a specific type. It's a type of factoring. So here we go. Let's do it like this. A type of factoring where you divide separate groups. It keeps jumping on you. Separate groups. Wow. UPS. There we go. And let's get out a different colored pen. I want blue. I want to go down to 1 point. All right, so here we go. So let's say we had t to the third power minus t squared minus 9t minus 9, okay? Let's say we had that to factor. To factor by grouping, what we're going to do is we're going to pair the first two and pair the second two together, all right? And so the first two, I can divide out of both of those a t squared. I can take a t squared out of both of those. And that'll leave me with a t minus 1. Okay? T cubed divided by t squared is t. T squared divided by t squared is 1. All right, the second two I can divide out of negative 9. And that leaves me again with a t minus 1. All right, we'll go over more of this in depth a little bit later. But again, this is to show you the process of what we're doing. So you notice how we have the same thing twice. Right? They're both t minus 1. That is by design. All right? If you don't get the same thing, you can't go any further. All right? You've done something wrong. So what we're going to do, since we have the same thing, I can take my coefficients and make that one of them. So t squared minus 9. And make whatever is the same, the other one, t minus 1. Okay? That is the process of factoring by grouping. Basically what I have done is I have divided out a t minus 1 from those, and this is what's left over. Okay? Now this is not factored completely, because I can take the t squared minus 9 and go further with it. Okay? So this is not completely factored, but this is the process of factoring by grouping. If I wanted to completely do it, I would break it down to t minus 3, t plus 3, and t minus 1, because that's what this one breaks down to. And we'll talk more about that later, okay? But that's factoring by grouping. Any questions so far? All right, let's do a few of these. Letter A, factor each polynomial completely. Okay, so the first thing, first things first, can you divide anything out of number 1?
No.
What about the x's?
Wait.
Yeah, they all have an x, right?
By 3. No.
How many x's can I divide out?
By 3.
Well, let me ask you.
1.
Yeah, this one has 3, right? This one has 2, that one only has 1. So how many can I take out total? 1. I can only remove 1 from all of them. So here we go. We got x. And then what's x cubed divided by x? X squared. What's negative 4x squared divided by x? Good. And what's negative 5x divided by x? Negative 5. Cool? So that's factoring by dividing something out. All right? Do we still have an x squared to deal with?
Yeah.
Yeah, okay, so let's go again. So let's pull out your parentheses. So what are 2 things that multiply to the left? Good, and x times x is x squared. Okay, what are 2 things that multiply to the right, the negative 5? 1 and 5, that's pretty much your only options, you're right. But how would the signs be? If you're trying to get back to a negative 4, what would the signs be?
Positive and negative. Positive and negative.
They'd be different. Which one's positive? The 1 is positive. The 1 is positive. The 5 is negative. Because remember, you got to do the outside times the inside. So x times 1 is x. Negative 5 times x is negative 5x. And those add up to a negative 4. That's your middle term. Okay? That's what's going on there. Let me erase that. Why did I erase it? Because I didn't need it. But this is factored completely. Okay? There's no more x squared to deal with. Nothing you can divide out. That is done completely. All right? Let's do letter B. Letter B is the same idea, but it's just a little bit different. Okay? So you got a binomial in this one. And remember, if we have a binomial, what's in the middle? What is the coefficient right here?
0.
0. It's not there because it's a 0. We don't write plus 0. So everything has to kind of cancel out as we go. So let's start here. Pull out your parentheses. And then since we're going back up to 0, everything we do is going to be just something times itself, right? Because it's got to be able to cancel itself out. So what times itself is 16? 4. 4 times 4 is 16. What times itself is y to the 4th? Not y to the 3rd, y squared. Good, y to the 2nd power. Because y to the 2nd times y to the 2nd is y to the 4th. Okay, what about the 81? What times itself is 81? 9. But they have which one's positive and which one's negative, or does it matter? Doesn't matter. So we'll make the first one positive, second one negative. Okay? And just to prove that this works, no, you don't have to write this down. 4 times negative 9 is negative 36, y squared. 9 times 4 is positive 36, y squared. And those equal 0. That's your middle term. Okay? But we're not factoring once, we're factoring completely. Do we still have a y squared to deal with? Yes. So odds are we can go further. The question here is, can I factor that one any further? Here's the problem. Remember the middle term is 0? Is there anything I can multiply to a positive that I can ever go back and get to a 0? No. Like a positive 3 and a positive 3 just get more positive. A negative 3 and a negative 3 just get more negative. This one is actually unfactorable. It is as far as it goes, without getting into funky decimals and weird stuff. This is actually probably an imaginary factor, to be honest with you. Imaginary roots. So that one is as far as it can go. So I'm going to drag it down. 4y squared plus 9. Okay. The one on the right, however, because it has that negative, we can get back to 0. Okay? So pull out your parentheses. What are two things that multiply to 4? 2. So 2y and 2y. What are we going to put on the right? 3 and... Thank you, Miss Rowland. She got a stack of them. If you don't have notes, go grab one. If you don't have notes, she's got to grab right there in front of the Alg2 box. Holy cow, not everybody at once. I'm starting to think so. You know what? I'll just say 7th period is SOL if they do, because most of these are students that have one but don't have it today. You follow me? That's what most of this is. But a few of them are new students. Just leave it. I only have 2 more periods. Just leave it. Don't sweat it. Okay. Okay. Cool. All right, so we got 3 times 3 to get up to a -9. So again, one of them's positive and one of them's negative. And that is factored completely. Cool? All right, so let's try one on your own. Let me zoom out. Letter D. And if you just got a packet now and you want to just write these down for the moment, that's fine. But letter D, try letter D. I'll give you a hint. It's a lot like letter A. Oh. All right, try letter D. Pause the video. Boop. I said D. All right, so hopefully you got down to that point. Did you at least get the first one? Did I say C?
Yeah.
Not bad.
I just erased it.
No, you think I said D? Ha ha! Sorry, she read it all out. Thank you.
So it's D or confusion?
I'm confusion.
Your confusion? Hi, confusion. I'm Mr. Hunter. Pleasure to meet you. I'm a dad. I'm allowed to say those jokes, okay? Give me a break. All right. So, again, just like letter A, I can divide it an X out of all 3 of those. And from that one factors down just a little bit further. All right. Letter C, if you want to do letter C is very similar to it as well, okay? So, what can I divide out of everything for letter C? Those of you who did it.
5.
I can divide them all by 5, okay? All right. Oops. Let's go back. What else can I divide them all by? A Z. How many Z's can I pull out? 2. Each of them all have Jonathan. All right. So if I'm dividing out of 5z squared, you should be left with z squared plus 6z plus 9 is what you should have gotten on the inside. Okay. Divide them all by 5 and all of them by z squared. And then we go one step further. Okay. So break out your parentheses. What are we putting on the left-hand side? Z's. All right. What are we putting on the right-hand side? 3's, because 3 times 3 is 9. What are the signs for them? They're both positive, because a positive 3 and a positive 3 will get me back up to that 6z. All right. And so that would be letter C. It is also just like letter A, except you're dividing out just something a little bit bigger. You follow me? Something bigger than just a single variable. All right? So again, I'll back out. All right? But any questions on C? If you can do C, you can do D. Maybe. I don't know. All right. Try letter F. I know I'm saying F this time. I'll give you a hint. F is a lot like B. Do letter F.
Why the letters?
Because it's D, F, E.
Yeah. Yep.
A, B, C, D, E,
F.
Oh! You know what?
Whoa.
I'm dyslexic. What are you going to do? All right, letter F.
What?
Look.
Oh, remember,
What's up?
I didn't get that when you said that.
Oh.
What's up, Terry?
Oh, somebody said it right.
That's fine. They don't need it, obviously.
Let them get a lot of fun.
All right, do letter F. Do letter F. It is a lot like letter B. Do letter F. All right, let's put this on the board.
No, that's not for nothing.
Here we go. All right. You still working? Finish up real quick, but check what you did. Hopefully everybody got the first step. Did everybody at least get the first step?
I forgot to flip the sign.
Ah, that's a problem.
Is that wrong too?
I see what you did. This one you can factor,
Boom, I got it
but
right.
that one you cannot. So that should be the plus.
Oh.
These two multiply up back to that one. Does that make sense? So here's the deal.
You put it in different way.
If I put this one first or this one last, it doesn't matter. Like I did that on purpose for that reason, to show that. All right, so here's the deal. Which one of these two can I not factor? The first one or the second one?
Second.
The second one, because it's positive. There's nothing that multiplies to positive that can give it back to 0. So this one is stuck. Okay? No further. Yes, it has an x squared. No, you can't go any further. All right, but this one you can. Okay? Any questions about this problem?
No, sir.
All right. Yes, ma'am. Go. All right, go. Turn the page. Let's go. Turn the page. What was that? What was that, dude? All right, so here we go. This is a special pattern. You'll already know one special pattern, whether you realize it or not. That's the difference of squares. So, like, if you had x squared plus, not plus, x squared minus 9, this is actually called a difference of squares because I can take the square roots of those. Those factor down to, what? X plus what? And x minus? Good. You'll already know that's actually a special pattern. It's called a difference of squares. Okay? Let's say if I had x, let's do this. Let's jack with you a little bit. What if I did x plus 10 or minus 10? Could I do that one?
Positive 5.
I mean,
What times itself is 10?
nothing. Square root of 10.
I know. Dirty, rotten trick. But the square root of 10 times the square root of 10 is 10. Okay? All right? Yeah, that's going to creep back up eventually, but we'll do that. For the time being, just go with it. All right? Cubes. We can also factor difference of cubes. So if I have something that's cubed plus something that's cubed, or something that's cubed minus something that's cubed. Okay? Now, they give this as 2 rules. This is really 1 rule. You just got to follow your signs. Okay? You just got to follow your signs. So here's the pattern. First things first, you take the third root of all of them. So basically, the third root of a cubed is a. The third root of b cubed is b. All right? I just take the third root of both of them. That's my first piece. From here, what we're going to do is I'm going to square the first one. If I square the first one, notice how that's just the first one squared. I multiply them together, but flip the sign. I multiply them together, but change the sign. Cool. And then last but not least, I square the back one. I square the back one. All right? We'll do a few of these so it makes a little more sense. But that's the pattern. I'll square the first one, multiply them together, flip the sign, then square the back one. All right, so here we go. Let's get an example going. So let's do 8x squared plus 125. Okay? 8x squared plus 125, that's your example. First things first, the cube root. What times itself 3 times is 8? 2. 2 times 2 is 4, times 2 is 8. That should be an x cubed, by the way, I apologize. So 2x. Does anybody know the cube root of 125?
25.
It's lower than you think.
5.
5.
Oh, yeah.
5 times 5 is 25. 25 times 5 is 125. Now, you okay over there? Now, I would venture to say you probably need to know your cubes like 1 through 5. Like 1 to the third power is 1. 2 to the third power is 8. What's 3 to the third power?
18.
27. 3 times 3 is 9. 9 times 3 is 27. Anybody know what 4 to the third power is? That was a good guess, whoever said that. 64. 4 times 4 is 16. 16 times 4 is 64. And 5 to the third power is? 125. Okay? Beyond that, yeah, use your calculator. But those ones you should probably know. All right, and we'll use them enough that you don't have to sit there and try and memorize them. You'll get them after a while. All right, so here's the pattern. Remember, we're going to square the first one, multiply them together but flip it, and then square the back one. Square the first one, multiply them together, flip the sign, square the back one. So, what is 2x squared?
2x.
4x to the second power. 2 times 2 is 4. X times x is x squared. Yes, sir. Never mind. Multiply them together. What's 2x times 5?
10.
10x. But flip the sign, it becomes a negative 10x. Okay? Now, square the back one. What's 5 squared? 25. And that's it. Okay? That's the pattern. It is easy. You just got to get used to the pattern. That's all. Okay? That is the pattern. Now, this one, yes, it has an x squared. No, it cannot go any further. Okay? There is nothing I can multiply to the outside that will ever get me back to a negative 10. So this one is stuck where it is. Okay? Cool. Let's do another one. So that's the one with the positives. Let's do the one with the negatives. Okay, so I'll do the exact same example, but I'll put a negative. So 8x to the third power minus 125. And y'all can walk me through it a little bit. Let's scoot it up. What is the third root of 8x to the third? 2x, very good. What is the third root of negative 125? Negative 5. Good. Because a negative times a negative times a negative is still a negative. Cool? And then there's your pattern. Square the front, multiply them together but flip it, square the back. So what's 2x times 2x? Okay. Multiply them together, what's 2 times negative 5? Negative 10, but flip it, it becomes a positive 10. And then square the back. Negative 5 times negative 5 is?
25.
Positive 25. All right? And that's it. All right? Now, if anybody's wondering why we flip this, the reason we flip this is because without flipping this one, we will not get rid of the middle terms here. You follow me? The middle terms are both zeros. Flipping that sign helps us to get rid of those two middle terms. All right? All right. Try letter A. Try letter A on your own. Cube root them, then front, both, but flip it, and then the back. It is a minus 1. But again, it's the same pattern. I don't know, is it?
You're the teacher.
Nice answer. Yeah, it is. All right, check the board. See how you did.
Bro, I had that.
That's it?
That's it right there. This is a one-step problem. All right, that's all this is, one-step problem. Okay? Again, you cube root both of them, get x minus 5. And then based upon this is where you get the rest of it. Square the front to get x squared. Multiply them together, but flip it to get a positive 5. And then square the back, get positive 25.
Multiply together, flip it.
Yeah, so negative 5 times x is negative 5x, but make it positive, flip the sign. All right? If you did it and got it right, great! Do letter B. If you did it and get it wrong, great! Redeem yourself, do letter B. Sweet? Do letter B.
Okay.
It's on the board.
Why this one is in a square? Like,
You would.
I mean, it's not a square.
I don't understand this part. Like, how did I get this one?
All right. Are we okay with letter B? Did we redeem ourselves a little bit?
Yeah, I kind of did.
All right.
I kind of did.
All right, letter C. Let's look at letter C real fast. Letter C. All right, letter C.
Mr. Hunter.
So what?
I did it.
All right, they're perfect cubes. It just has an extra letter. So what is the third root of 27? Not 9. 3. So I got 3. What's the third root of x to the third power? X. What's the third root of 64? 4. What's the third root of y cubed?
Y.
Y. All right. It's just y. All right. Why? I don't know why. Do you know why? Don't say it. All right. So here we go. Basically, this is the hardest part for most students. They see this and they go, "Oh my gosh, 2 variables. I'm not going to do that." And they shut down and they stop. It's not that hard. I just do them both individually. And from here, I follow the exact same pattern. Square the front, multiply them together and flip it, square the back. So what is 3x times 3x? 9x squared. Okay, multiply them together. What's 3 times 4?
12.
But flip it, make it a negative 12. And what is x times y? xy. There, no z. Then square the back. What's 4y times 4y? 16y squared. And that's your answer. Cool? Do letter D. I'm going to dig this pattern in you today. Do letter D.
Mr. Hunter, I didn't finish letter 2.
All right, finish letter B. Finish letter B then.
You mean letter D, not B?
I love that part.
All right, how are we doing?
Doing good. I got that.
I got that except that I just put 6x here and 6t.
Oh, if you put the t, then the x, that's fine. X times t is the same as t times x. Doesn't matter. Peace.
Bye.
Still got a bum knee?
Yeah.
Okay, fair enough.
Likeable.
Body cripple, is that what you said? You're a horrible person. All right, here we go. All right, last one of the day. Last one of the day. We'll call it quits. Letter E. Before we start doing things to this, is there something we can divide out? 16 doesn't go into 64. 9 doesn't go into 64. I can take out the S's. That's true. I can pull out the S's. I could also take out a 2. It's the biggest number I can take out. I know it looks like I should be able to take out 8, but 8 goes into 56, not 54. 4 goes into 52, not 54. But anyways, what's 16 divided by 2? 8. What's s to the 5th divided by s squared? S to the 3rd. Good. What's 54 divided by 2? 27. Very good. What's s squared divided by s squared?
S. Not
Let me ask you, is it 1 or 0?
1.
1. Anything divided by itself is 1. Okay? Now, that is a sum of cubes. So 2s squared, let's break it up. What's the third power is 8? 2, so 2s. What the third power is 27? 3. So knock it out. What's your first term going to be? 4s squared. Remember, 2s times 2s. What's the second term going to be? Positive or negative? Negative 6s. Good. Multiply them together, flip the sign. What's the last term going to be? Positive 9. 9? And there you go. All right, so that is factored completely. Yeah, we had to do it twice. So what?
Oh, well.
Cool? All right, we'll pick up this tomorrow and go from there.